Hello. Today we will have a discussion on the ELECTRE method. This is another multi-criteria decision-making method which is being used for a long time, and it comes under the outranking method. As I have already discussed, there are two types of MCDM methods. Now, in in one type, this is known as compensatory MCDM method. Example is HP, ANP, then you WSM, WPM, etc. In case of compensatory method, the decision is made based on a value, which is also known as the weightage of importance. Now, in another kind of method, which is known as outranking method, the example of which is your ELECTRE, Prometheus, and other EVAMIX, etc. methods. Now, in this case, the decision is made by outranking one alternative from the other. Suppose if there is three alternatives, if A1 outranks A2 and A2 outranks A3, then A1 is your selected alternative. In case of outranking method, there is no value given, no weightage of importance given. Only thing is that they give a procedure by which you can outrank one alternative from the other, and thus you can select the best alternative among the available alternatives. Now, ELECTRE is a outranking method which has been invented in France, and this method is now used in all over the world. Now, the basic difference between the ELECTRE method and the other method, AHP, NB, etc., is that there is no condition that your alternatives and criteria must be in a numerical value or in a qualitative value. No such criteria is given or conditions are given, and also there is no need of defining an alternative as a beneficiary or non-beneficiary. You do not need any definition which indicates that this alternative is beneficiary, this alternative is non-beneficiary. Same for criteria. You do not need or do not require to define the criteria in beneficiary or non-beneficiary. The procedure itself will select which one is beneficiary, which one is not beneficiary. Now let us take an example. I have already used the buy a car example to explain most of the methods. So here our decision goal is to buy a car. Our criteria is cost and speed, and our alternative is Mercedes, Jaguar, and Toyota. So here we will use the ELECTRE method. Yes, so let us first the first step of the ELECTRE method is we must develop the alternative indicator matrix. Now here the alternative indicator matrix means these are the alternatives, these are the criteria, and these are their values. Okay, all example values, so or arbitrary values, and this is just to show how the method works. So this matrix is known as alternative indicator matrix. These are the alternative, these are the criteria, and these values are the indicators. Okay, so this is, there is nothing very significant about this step. So basically this matrix gives you what are the value of the criteria with respect to the alternatives. Now the next step is the norm to develop the normalized indicator matrix or the normalized decision matrix. Here what happens is we square each term, okay, and then add it, and after that we square root it, okay, and then the value that we get, we divide that value from each of the indicator. That means we divide this value from 80, from 100, from 120, and same for when we add and square root. Let us take this as y. So these become y, y, and y. So after doing this, what will happen is you will get the normalized decision matrix or normalized indicator matrix. Okay. So here this process is just shown. These are the, as you can easily understand, 80 square is 6400, and all the square we have sum it, square root it, and then divide it, and this matrix has come. This is your normalized decision matrix. Okay. After we have developed this normalized decision matrix, what will happen is we have to develop the weighted normalized decision matrix. Now here comes the uh, limitation or drawback of ELECTRE method. You see the weightage of cost and speed, the criteria here is determined by the decision maker. In case of HP, as you remember, we have a criteria matrix which gives you the weightage of the criteria. In case of ANP also, and just in case of WSM and WPM, the weightage of criteria or weightage of importance of the criteria is indicated by the decision maker. So when the decision maker changes, these weightage can also change. Now, so what will be the next step to develop the weighted normalization matrix? Yes, just multiply the weight of indicator with the normalized value of the alternatives. 0.6 multiplied by 0.56, 0.6 multiplied by 0.570, 0.6 multiplied by 0.684, same, 0.4 multiplied by this, 0.4 multiplied by this, and 0.4 multiplied by 0.570, and this will be your result, right? And here you know this is your weighted normalized decision matrix. When I compare Mercedes with respect to Jaguar, what will happen? Mercedes with respect to Jaguar based on cost. Mercedes is 0.274 cost. Jaguar is 0.342. It is not greater than Jaguar. And also in case of speed, 0.12 is not greater than 0.274. So that is why we write a 0 here. Same case is this. If I compare Mercedes-Benz with respect to Toyota based on cost and speed, the value in the normalized matrix for Mercedes is less than the value in normalized matrix for Jaguar. So that is why for in the both the case 0 has been given. But when I compare Jaguar with respect to Mercedes, what happens? The Jaguar, the value of Jaguar with respect to cost, with respect to Mercedes based on cost is greater. That means the value of Jaguar is 0.342, value of Mercedes is 0.274, 0.342 is of course greater than 0.274. So what we do is we write the weightage of importance or weightage of the indicated cost here as the value of cost for Jaguar is more than the value of cost for Mercedes. Now in case of speed also 0.274 is greater than 0.182. That is why the weightage of the speed indicated speed criteria is also added here, and this will become 1. And in this, when we compare Jaguar with Toyota, what we see is Jaguar with Toyota, what happens? The value of Toyota is greater than Jaguar in case of cost, but less than Jaguar in case of speed. So what happens? The weightage of indicator or weightage of that criteria has been placed here for speed, but for cost, as it is not greater, we are giving a 0. So similarly for Toyota, similarly for uh, when Toyota is compared with Mercedes, both the values are greater than Mercedes, so both the weights are given here. This is the weights of cost, this is the weights of speed, and then we also compare Toyota with Jaguar, and what happens? You see Toyota with Jaguar, it is greater, so the weights are written here. This is 0.6. And when we compare Toyota with Jaguar in case of speed, it is less, so it will be 0. Now what's happened? Now your question will be, why the diagonal is 0? In case of HP we have 1, right? The reason for the diagonal to be 0 is, you see, the value of Mercedes-Benz with respect to the value of Mercedes-Benz will always be equal. They can never be greater than each other. So that is why they will be 0. They will be always 0 because we are comparing the same alternative with the same alternative. So naturally, no one will be greater than the other. So we have a 0. Now this creates the first type of concordance matrix, and then I have already said what happened. You see, you are adding this, so this matrix will become this, and then what you will do is you add this value plus this value plus this value, then you add this value plus this value plus this value, then you add this value plus this value plus this value, then you add this value plus this value plus this value. Now what happens is, this will give you, suppose what I say, this will give you 2 plus 1, 3. Now you see in this matrix, how many non-zero number is there? how many non-zero number is there? As you see, this one is 1, this one is 2, this one is 3, this one is 4. So there are 4 non-zero numbers. So you will divide this 3 by 4 to get the C bar value. Okay, this is also known as concordance value or concordance threshold or concordance bar value. So here, as you can see, except this one, all values in this matrix is less than 0.75. That is why in this concordance set, this matrix is known as concordance set. Here you can see only for these two values, this value and this value, we have given 1, 1. But all other values are 0. So we have found our concordance set. The next step will be to find the discordance matrix and discordance set. Now here what happens is you just deduct the values of cost of second alternative from the first alternative, and then value of cost from the third alternative or from the second alternative by the third alternative. M minus J. M is the first alternative, Jaguar is J is the second alternative, and Toyota is the third alternative. So what here we are doing is A1 minus A2 for both cost and speed. 0.274 minus 0.342. Okay. Then A2 minus A3. Yes. Oh, sorry. A1 minus A3. A1 minus A3. M minus T. Both cost and speed. Then A2 minus A3. A2 minus A3. And then A2 minus A1. Right? A2 minus A3. This is A2, this is A3. And then A2 minus A1. This is A2, this is A1. And lastly, A3 minus A1. And then A3 minus A2. Note this sequence must be followed. You must first deduct A2 from A1, deduct A3 from A1, then you go to A2, deduct A3 from A2, and then deduct A1 from A2. After that you go for A3, deduct A1 from A3, deduct A2 from A3. This sequence must be maintained. After doing that, can you do this for both value of cost and speed? Now, the next step, what happens is, after deductions are completed, these values are, we have derived these values, right? And, yes, so how? Now, what will happen is, first you compare that which one is the maximum value in this row. Which one is the maximum value in this row? The maximum value in this row is 0.091, correct? Now I say which one is the maximum value within the negative values only. This is the negative value. This is the negative value. And now which one will be the maximum? This one will be the maximum. Always 0.091 is greater than 0.068. So first you compare all the values and try to find out the maximum value, and then you compare only the negative values, and there you try to find out the maximum value, and then divide the maximum value within the negatives by the maximum value within all the values. Here, interestingly, you see the maximum value within all the values is 0.091, and the maximum value within the negative value is also 0.091. So when we divide this, what happens is we get a 1. Okay. Again, for this one, you see which one is the maximum value. Here also, interestingly, 0.137 among all the values. Among the negatives, 0.137. So you divide each other and you get 1. When dividing, you must ignore the negative sign. Okay. Then comes this one. Here there is no negative value. So which one will be your highest value? Here I can see 0.091 is the highest value. So what happens is, here we get the same thing, only one value is there, no negatives are there. So it will become 1. After then you go for this. Here also the maximum value within all the values is 0.068, and within only the negative there is only one negative, so this one will be the maximum value. So divide it and 1 will come, and so on. And this you will do for all these deductions. That means for A1 minus A2, then A1 minus A3, then A2 minus A3, then A2 minus A2 minus A1, then A3 minus A1, and A3 minus A2. After that, we'll go to the next matrix. What will happen? This matrix will be created, and when we are creating this matrix, what happens is, you see, if I go to the earlier section, you will see when M, this means this is your A1, this is your A1, this is A2, this is A1, this is A2. So when A1 minus A2 is considered, we have found that the maximum value within all the value and maximum value within the negatives only is same. So 1 is come. And same thing is there for A1 and A3. Yes. Then A2, A1, then A2, A3, 1, then A3, A1, A3, A2, and A3. A3 is nothing but 0. Okay, because no greater, no less. After that, as per the same as the matrix for concordance, what we do is we just add these values, right? 0 plus 1 plus 1, 2, 1 plus 0 plus 0.667, 1.667, then 1 plus 1 plus 0, 2. And then add these values, same as the concordance matrix, and we get 5.667. Now we divide it by the number of non-zero values. Here how many non-zero values is there? 1, 2, 3, 4, 5, 6. So there are 6 non-zero values in this matrix. So we divide this value by 6 to find the D bar, value. Then we compare this D bar value with these values. 0 compared to D bar, which one is greater? D bar is greater, so 0 will be given. 1 compared to D bar, which one is greater? 1 is greater, so here 1 will come. In case of Toyota, 1 compared to 0.945, which one is greater, 1 is greater, this one, and so on. Whenever this value is greater than the d bar, we give 1, if not, we give 0. Okay. So by this way, we find the discordance set. Same thing as concordance set, only difference is in case of discordance, we do these subtractions, and in case of concordance, we compare the values. The value which is greater, the weightage of that indicator is placed in the matrix, and if for all the criteria or more than one criteria, the value is greater than the other alternative, then we add it. If not, we place 0 for those criteria for which the value is not greater than the other alternative or the alternative with which the comparison is going on. So in this way, concordance set and discordance set is created. This is the last step of ELECTRE, where we actually aggregate the concordance set with the discordance set. And this is basically an AND operation. AND operation means multiplication operation. So what I mean is 0 multiplies 0 comes 0. 0 multiply 1, this is AND operation, it comes 0. 0 multiplied by 1, this is AND operation, 0. 1 multiplied by 1, 1. 0 multiplied by 0, 0. 0 multiplied by 1, 0. 1 multiplied by 1, yes, 1. 0 multiplied by 0, 0. 0 multiplied by 0 is 0. This is basically an AND operation between two matrices. And this is your, what I will say is the final matrix. And from here, what we found is Jaguar, when I compare Jaguar with Mercedes-Benz, Jaguar is more important than Mercedes because there is a 1 here. And when you compare Toyota with Mercedes-Benz, we find that Toyota is more important to Mercedes-Benz, more important than Mercedes-Benz, because whenever there is a 1, and if this is the alternative with which you are comparing the other alternatives, then the alternative which you are comparing becomes more important. Here we are comparing Jaguar with Mercedes-Benz, and there is a 1, so Jaguar is more important compared to Mercedes-Benz. And in case of Toyota, there is 1, so Toyota is more important than Mercedes-Benz. Now the question arises, Jaguar is more important to Mercedes, Toyota is more important to Mercedes. What about Jaguar and Toyota? Because when I compare this Jaguar and Toyota, for both the cases 0 has been come. So this can be concluded that both Jaguar and Toyota is more important to Mercedes. But if I say that Jaguar is the most important alternative among Mercedes, Jaguar and Toyota, it is incorrect. Because we are undefined or inconclusive when we are comparing Jaguar and Toyota. Because here, when you are comparing Jaguar with Toyota, 0 has come. So that implies that here, two alternative is more important than the other alternatives. That means Jaguar and Toyota is more important than your Mercedes-Benz. But you cannot say that Jaguar is more important than Toyota or Toyota is more important to Jaguar, because the last matrix, the cross matrix between the concordance and discordance set, has resulted in an inconclusive selection. This is another drawback of ELECTRE. I have already said that there is one drawback, that the weightage of the indicators or weightage of the criteria is given by the decision maker. So when decision maker changes, weightage can change. And this is the second drawback, that it may come that two or more alternative, between two or more alternative, you cannot select the better alternative because your cross matrix between concordance and discordance has resulted in an inconclusive result. Okay. So thank you. And if you have any questions, you can share with me in the comment box or in my WhatsApp. Mainly, just remember that ELECTRE is a outranking method, and mainly there are very few steps to find the most significant alternative by ELECTRE, which is the first step is your what is the first step? First step is your normalization by square root. Second step is your that weighting or weighing the normalized matrix. Then find concordance, find discordance, and ultimately find the cross between the concordance and discordance set to find the result. But this method has two major drawbacks. First one is weighing of the normalized matrix, where DM or decision maker gives the weightage. So when decision maker changes, weightage can change. Second is the C cross D may yield a inconclusive result. Okay, so these are the two major drawbacks of that ELECTRE method. Thank you.